Now let's see how we can implement caching in our app. So let's say we want to store our listings in a cache so they're available if the device goes offline. So earlier I told you that we have 3 options for caching data. We can use async storage, secure store, or SQLite. Now for caching the listings, it doesn't make sense to use secure store because it has a very limited size and we should use it only for storing sensitive data. So we're left with 2 options. SQLite is useful if you want to execute queries on relational data, but here we just want to store an array of objects in the cache and retrieve it later on if we can't get it from the server. Here we don't have complex relational data that we need to query. So we're left with one option, async storage. Now on Android, async storage uses SQLite under the hood, but on iOS, it stores data either in a serialized dictionary or in separate files, depending on the size of the data. That's an implementation detail we don't have to worry about. So we just store key value pairs in async storage and let it figure out how to store them on each platform. Having said that, we shouldn't use async storage directly. We should hide it behind a cache layer that we can easily use in our app. So our cache layer is going to automatically serialize or deserialize objects, so we don't have to call json.stringify or json.parse every single time. Our cache layer is also going to apply a timestamp to each item and then figure out if the item is expired or not. And if expired, it can automatically clean up async storage to free up some space. That's why we need a layer or an abstraction on top of async storage. Without this layer, these details would leak to our application code. If tomorrow we decide to change how we want to store data in the cache or change the expiry logic, then we'll have to modify a million places in the code. We don't want that. We want to encapsulate all these details in a single place, and that's why we need a caching layer. So next, let's see how we can implement a caching layer. So here in the app folder, let's add a new folder called utility. And in this folder, let's add a new file called cache.js. Then here we're going to import async storage from React Native. Then we're going to define a function called store, which takes a key and a value. Now, before I forget, let's export a default object with the store method. Then here we're going to call async storage.setItem. We pass the key. Now we can optionally add a prefix like cache. It's just my personal preference. You don't have to do this. So we don't want to hard code this here. We want to store it in a constant that we can reuse in multiple places in our code. So prefix equals cache, and then we can use it right here. So we pass the key, and then for the value, first we have to serialize it as a string. So we call json.stringify. With this, we don't have to remember to call this method every time we want to store something in the cache. So that is one of the benefits of this layer. This method returns a promise, so we have to await it and then mark this function as async. Now, because we're using await here, we should wrap this code inside a try catch block. So let's add that real quick. Good. So if something goes wrong, for now, we're going to log something on the console. Okay. As I told you in the last video, our cache layer should also apply a timestamp to each item. With this, we can determine if an item is expired or not. So instead of storing the value directly, let's define an object called item. This object is going to have 2 properties. One is the value that gets passed from the outside, and the other is a timestamp. We can set that to date.now. Now, let's add it over here. Good. So our store function is ready. Now let's implement the get function. So get is a function that takes a key. Now let's export this from this module. So in this function, we're going to call async storage.getItem. We pass the prefix plus the key. We get a promise, so we await it to get the stored value. Now let's make this function async. So this value is a string. Now we need to parse it as a JSON object. So json.parse. With this, we get the actual item. That is the item we created earlier. So this object over here. Now here we should wrap this code inside a try catch block. So try catch, good. Let's move this code up here and in the catch block, let's log the error on the console. Okay, so we get the item. Now here we have a few scenarios. One scenario is where the item doesn't exist. So if we don't have this item, we're going to return null. The second scenario is where the item exists, but it's expired. To calculate expiry, I'm going to use moment.js. It's a very popular library for working with datetime objects. You're probably familiar with it, and you're probably going to say, hey, Mosh, but there are more lightweight alternatives. I'm aware of that, but I want to deliberately use moment.js here so we can talk about optimization in the future. So let's install Moment. Good. Now, here on the top, let's import Moment from Moment. Now, to see if the item is expired or not, first we get the current date time. So now equals moment of date.now. We should create a second moment object for the timestamp of this item. So let's call that stored time. We set it to moment. And here we pass item.timestamp. Next, we calculate the difference. So diff equals now the diff. Here we pass stored time. And as the unit, we specify minutes. Now let's make an assumption. If the item was stored more than 5 minutes ago, we can say it's expired. So let's rename this to is expired and turn this to a Boolean expression. Now we don't want to hard code this value here. We should define it as a constant on the top. So let's call that expiry in minutes. Now potentially in the future, we can store this in a configuration file, but let's not worry about it at this stage. So if the item is expired, then we should return null. Now here we can also clean up the cache. So we call async storage.remove item and pass prefix plus key. This returns a promise, so we should await it. Now here we are violating an important principle in programming called command query separation, or CQS principle. This principle says that our functions or methods should either be commands or queries, but not both. A command function is a function that changes the state of the system. A query function is a function that returns the state of the system. In this case, our get function is a query function because with this, we're querying data. So in the middle of this function, we should not change the state of the system. This is a violation of the command query principle. But in this case, it's okay to violate this principle. It's not the end of the world. We are doing this for a good reason. We don't want to store too much data in the async storage. So we're consciously breaking the rules. So we're done with the second scenario. Now, if we get to this point, that means we have an item that is not expired. So we're going to return item.value. We're almost done. The last thing I want to do here is to extract this logic and put it somewhere else, because this is violating the single responsibility principle. Because our get function now has two responsibilities. One responsibility is getting an item from the cache. The other responsibility is detecting if the item is expired or not. These are two separate responsibilities. Our functions or methods should have a single responsibility. So I want to move this logic somewhere else. Let's define another function called isExpired. It takes an item. Now, let's grab these 3 lines and move them right here. So we give this function an item, and it tells us if the item is expired or not. Okay? So at the end, we can simply return the value of this expression. Now, let's call this function. So if this item is expired, then we're going to remove it from the cache and return null. So we're done with our cache layer. Next, we're going to use it in our API layer. Now that we have a cache layer, let's bring it into our API layer. So in the API folder, look at listings.js. Here we have this function for getting the listings from the server. Now we should change the logic here. So if we can successfully get the data from the server, we should store it in the cache. And if the call to the server fails for any reasons, then we should get the data from the cache, assuming it's available. But we don't want to implement that logic here, because if tomorrow we decide to cache the list of messages as well, then we'll have to duplicate that logic somewhere else. So we want to have a single place for providing data from the cache. And that is our client module here. This is the only module that knows how to call the server. So our caching logic should also be implemented here, right? So on the top, let's import cache from, we go up to utility/cache. So we create an API client. Now this client object has a method for getting data from the server. We should change the implementation of this method. So if we can't call the server, we can look for the data in the cache. But how can we change the implementation of this method? Very easy. First, we get a reference to this method and store it in a separate constant. Then we redefine API client.get. So we set it to a new function. In this function, we can call the original get method, in this case, the get function. And in addition to this, we can execute some code before and or after the call to the get function. This is how we can change the implementation of the get method. So look at the parameters of the get function. We have URL, params, and access config. We should add these parameters here as well. So our new get method has the same signature as the old one. So we can use it the same way, okay? So we add URL, params, and access config. And then we pass this as arguments to the original get function. So URL, params, and access config. So this function returns a promise. We await it to get a response. Now we should mark this as async. Now, if we can successfully call the server, so if response is okay, then we're going to store the data in the cache. So we call cache.store. For the key, I'm going to pass URL. And for the value, I'm going to pass response.data. Now, in this implementation, we're caching every GET request. In your app, this might not make sense. You may want to create a blacklist or a whitelist to cache certain requests, okay? So you store the data in the cache. Now, what should we return? We shouldn't return response.data. We should return the same object as the original get function. What does the original get function return? The response object. So let's return the response object. Now, if we get to this point, that means the call to the server failed. Maybe the server is offline or we don't have internet connection. Either way, you want to look for the data in the cache. So we call cache.get. For the key, I'm going to pass URL. This returns a promise. So we will wait it to get the data. Now, what should we return? Well, if the data exists, we should return an object that looks like a successful response. So we return an object with two properties, OK, which we set to true, and data. These are the only two properties that we really care about when using our API layer, right? So if we have the data, we return this simulated successful response. Otherwise, we want to return the original response object because this object contains information about why the call to the server failed, okay? So we're pretty much done here. Let's test our implementation. So save the changes. Here's our app. So I'm going to reload it. Now all the data should be stored in the cache. To test this, I'm going to turn off my Wi-Fi. So real quick. Okay, my Wi-Fi is off. Now let's reload the app. All right, our listings are here. These are the listings that we previously retrieved from the server. But the images are not here because we haven't cached the images. We have only cached the JSON object that we got from the server. That is an array of listings. In the next lesson, I'm going to show you how to cache the images as well. The best way to cache images is using this library called FastImage. It's a very popular library. Look at the number of downloads per month. It's over 280,000 times. So this library gives us an image component that is a replacement for the image component in React Native. It's a lot better. It supports caching, progressive loading, authorization headers, and so on. However, at this time, it's not available for Expo apps. So on this page, expo.canny.io, you can see feature requests that are submitted to the Expo team. So there is a request to add React Native FastImage. Currently, it has over 400 upvotes. If you really like fast image, you can upvote this request so it gets more attention from the Expo team. Now, all that aside, in this lesson, I'm going to show you an alternative library. So we have this library called React Native Expo Image Cache. This also gives us image caching and progressive loading. So let's copy this and install it using npm or yarn. Okay, now this component relies on Expo Blur. That's a library for applying a blur effect to images. Unfortunately, this is not documented on its GitHub page. So here we have to install Expo Blur using Expo. If you don't install this library, you're going to get a runtime error. So let's install this. Okay, good. Now let's go to our card component because this is where we have our images, right? So here's our image component. This is the image component that comes with React Native. We're going to replace this with a different image component. So on the top, let's remove this image component and import the image component from React Native Expo Image Cache. Okay. Now this component, unfortunately, has a slightly different API from the image component in React Native. So instead of the source property, we should set the URI property. So we set URI to a string, and in this case, that is image URL. So let's save the changes and reload our app. So we get this weird error. Let's reload the app. Okay, the error is gone, but we cannot get the listings because currently my Wi-Fi is turned off. So I'm going to turn it back on. All right, let's reload the app. Good. So all these images are now stored in the file system of this device. So if we go offline and reload the app, we still see the images. So caching is working. However, there is a tiny problem here. Let me reload the app. Note that the images will appear with a tiny delay. Take a look. Did you notice? Let me reload one more time. There you go. So to solve this problem, we can use progressive loading. So we get a very small thumbnail from the server and use it as a placeholder while the image is loading. So look at our listings API. Each listing has an array of images, and each image has two properties: URL, which is what we have used so far, and thumbnail URL, which is a small 100 by 100 pixel thumbnail. So every time we upload an image to the server, our node server automatically generates the thumbnail for us. So in your apps, if you want to support progressive image loading, your server should be able to generate thumbnails. Now, the good news is you don't have to code this yourself. You can use a cloud service called Cloudinary. So take a look, cloudinary.com. With this, we can automate your entire image management lifecycle. So you upload your images to Cloudinary, and Cloudinary automatically generates the thumbnails on the fly. Okay. So back to our app. We're going to use thumbnail URL to implement progressive loading. So our card component currently gets only the image URL. Let's add a new prop here, thumbnail URL. And then we're going to use that in our image component. So here we have a property called preview, which we set to an object with the URI property. We set this to thumbnail URL. Okay. Now save the changes. We have to go to our listings screen. This is where we're using the card component. So we should pass thumbnail URL and set it to item.images of 0, the thumbnail URL. Okay. Let's test our app. So here's our app. I'm going to turn on my Wi-Fi. Okay. Now let's reload the app. All right. Did you see progressive loading? One more time. So we saw the thumbnail with a blur effect. That is why we have to install Expo Blur in addition to this library. Okay. Now our thumbnail has a black tint that looks a bit ugly. Have a look. Do you see the black tint? We can easily change that. So back to our card component. Here we can set tint to light. Now let's reload one more time. That looks much better. One more time. Perfect. Now I'm going to turn off my Wi-Fi. Okay. So we are offline. Let's reload the app. So we have perfect offline support here. All the listings and their images appear. However, if we tap on a card, we don't see the image. This is not a problem with our caching. This is a bug in listing details screen. So let's fix that real quick. We go to listing details screen. So here's our image component. We are setting the source to listing.image. Our listing doesn't have a property called image. So this should be images of 0. We want to show the first image. Now in the future, we can add a slider so the user can slide between multiple images. Now here we can also use our new image component. So on the top, let's remove the image component from React Native and import the image component from React Native Expo image cache. Now, just like before, we're going to set the URI to listing.images of 0.url, and we're going to set preview to an object with the URI property set to listing.images of 0.thumbnail URL. We can also apply a tint of light. So we are using this image component exactly like the image component on our card. Okay. Now, here's our image. Beautiful. Let's pull this down. Look at another listing. Perfect. We also have that beautiful progressive loading effect. Did you notice that? Did you see the blur effect? It looks really nice. So we're done with this step. Let's move on to the next lesson. As you saw, I implemented caching in this app with very little effort. It took me less than 10 minutes to implement caching, right? Now, there is a common misconception that to add caching support to an app, we should use Redux. If you're not familiar with Redux, it's basically a state management library that often gets used in React and React Native apps. With Redux, we can store our entire application state inside an object that is available to any components in our app. You can think of it like a database for the front end. Now, Redux has a large ecosystem. There are a lot of plugins for Redux. For example, we have a library called Redux Persist that automatically persists the Redux store on the disk and rehydrates it when the app starts. So a lot of people use Redux to add caching and offline support to their apps. In fact, we have this guy over here. He loves Redux. He uses it for every single project. He cannot even think of a word without Redux. In fact, there are many guys like this out there. And in my opinion, that's a terrible thing that has happened in our front-end community. Because of this bad trend, we have a lot of apps that look like these buildings here. Look, I have nothing against Redux. In fact, I have a complete course on Redux. But there is a problem with Redux. It brings in so much complexity. Unfortunately, some people love this complexity because that's how they get their confidence and feel superior to others. I don't. I hate complexity. As Leonardo da Vinci said, simplicity is the ultimate sophistication. In this app, we added caching support with very little code that I wrote in less than 10 minutes. Our code is pretty simple and self-explanatory, and we don't have many moving parts. We introduced only the cache module and then brought it in the API module. If I wanted to build this app with Redux, I would have to write a lot more code. Our code and applications architecture would be more complex, and we would have many moving parts. We would have actions, action types, reducers, middleware, thunk, Redux Persist, just to name a few. There's actually more. Do you think this is an elegant solution to the caching problem? I don't think so. Now this guy is back. He says, Mosh, your implementation of caching is crap. It has all these problems. And my response is, why don't you improve it and make it fit for your app? Then he says, but Redux also gives us undo and redo functionality. And that's when I ask, do you really need it? And then he argues, but with Redux, you know exactly where the state of your app is, and you can go back in time. Again, I ask, does it really matter for the app you're building? So he keeps going with but. These arguments can go forever. I don't really like to participate in them. Again, I have nothing against Redux. I have a complete course on it. I think Redux is great, but not for every app on the planet. You should only use Redux if you have a complex data flow in your app. If you have multiple screens sharing the same piece of data that can get changed in different ways, and all these screens and components should be in sync, then go for Redux. Otherwise, you shouldn't use Redux. So I told you that we have 4 strategies for adding offline support to our apps. We talked about notifying the user, disabling certain features, and caching data. Now let's talk about the 4th strategy. When the device is offline, we can store users' actions locally in the app and then execute them later when the device goes online. Again, this is one of those moments that someone hearing the word action thinks we should use Redux. No, don't go there. We don't need Redux here. Again, we can modify our API layer. We can change the implementation of post, put, and delete methods. So if the call to the server fails, we can store these requests in our cache and then execute them later. If you have a simple app, this may totally work for you. But if you have a complex app and you want to support various actions offline, this can get pretty tricky. You have to handle optimistic updates, retrying actions, conflict resolution, and so on. It's just not worth it. I don't recommend you to implement this by hand from scratch, unless you have a really simple app. So if your app is complex and you want to have this level of offline support, then I would suggest you to look at Firebase. Firebase is a platform for building mobile apps. With Firebase, you get a real-time database, which is very powerful, but you will also get offline support and automatic synchronization. So if the user modifies the data when the device is offline, Firebase client automatically saves the changes locally, and then it will synchronize them with the cloud later when the device goes online. So Firebase is essentially going to be the backend of your app. So you wouldn't need the Node backend anymore. Now that would change a number of things, and that's why I didn't include it in the course. It's really outside the scope of this course. But here on the Expo documentation, you can read about using Firebase. It's really easy. So I leave it up to you to learn about it. Another option is to use Realm. With Realm, you can build fully featured apps without a network connection. So again, you get a client-side database that automatically synchronizes itself with the cloud. It's a very popular platform. But again, before you research any of these solutions, first you should ask, do you really need this level of offline support in your app or not? Many popular apps don't have this level of offline support. Twitter is an example. At the time of recording this, you cannot post a tweet when you're offline. So if this feature is not crucial for your app, don't overcomplicate things. You can simply disable certain features and show an offline notice to the user. As simple as that. Let's see how we can show an offline notice when the user's device is offline. So here in the components folder, I'm going to add a new file called offline-notice.js. First, I want to work on the look and feel of this component to make sure it has the right look and feel. Then I'm going to bring in netinfo to show this only when the device is offline. So here we have a container. Inside this container, I'm going to add an app text and say no internet connection. Now let's rename app text to text. That's cleaner. Now let's apply a bunch of styles here. So I want to set the background color of this container to colors.primary. Next, I'm going to give it a height of 50 pixels. Now I want to make sure that this always appears on the top. So I'm going to set the position to absolute. Now let's test our app up to this point. So save the changes. Here's a question. Where should we use this component? We don't want to add this to every single screen because that is repetitive. So we should add this to our app component. So here's our navigation container. Right above that, I'm going to add our offline notice. If the device is offline, this component is going to render that red bar, okay? Now, because we have multiple components here, we should wrap them inside a fragment. So we have a single element or a single component returned from this function. Okay, let's take a look. All right, we don't see our offline notice because it's covered by this screen. To solve this problem, here we should apply a z index of 1. This will bring this component to the top. So take a look. It's not here. Let's reload the app. Okay, here's our red bar. It looks a bit weird. So first, let's change the width to 100%. So width is 100%. All right, it looks better. Now we want to put this right below the notch on iPhone or the status bar on Android. To do that, on the top, we're going to import constants from expo-constants. We talked about this library in the first part of the course. So here I'm going to set the top property to constants.statusBarHeight. Now take a look. It's better. Now I want to put the text in the center of this container. That is super easy. Here we have to apply two properties, align items and justify content. We set both of these to center. Okay, that looks much better. Now, finally, I want to make the text white. So let's define a new style here. Text. We're going to set the color to colors.white. And then we're going to apply our new style here. Okay, take a look. That looks pretty good. Now, we want to show this only when the device is offline. So on the top, let's import useNetInfo from @ReactNative_community/netinfo. Now, we call this hook to get a netinfo object. Now, before working with this, let's just log it on the console. All right. Now, I'm going to reload the app. Okay. Now, in Metro Bundler, let's look at the log for this iPhone. So here's what we get. We get 3 objects logged on the console. Initially, the type of connection is unknown, and is internet reachable is false. At this point, we don't want to show the offline notice because the type of connection is not determined yet. So this is too early to show the notice. So look at our second object. At this point, the type of connection is determined. So we have a Wi-Fi connection, but we still don't know if internet is reachable or not, because at this point, netinfo is pinging a remote server to see if internet is reachable. So again, at this point, we don't want to show the offline notice. So we should show the offline notice only if the type of connection has been determined and is internet reachable is false. So let's remove console.log. If netinfo, the type is not unknown, and netinfo is internet reachable is false, then we want to render this container. So note that here I'm explicitly comparing this with false. I'm not treating this as a falsy, because if this property is null, then applying the not operator on null will produce true. We don't want that. So here we should explicitly check for a false value. So under these conditions, we're going to render the container. Otherwise, we're going to return null. Take a look. So let's reload the app. Okay, we don't see the notice. Now I'm going to turn off my Wi-Fi. Okay, here's the notice. It looks beautiful. Now if I turn the Wi-Fi back on, the notice doesn't go away. This is a problem with the simulator. If you test this on a real device, it works perfectly fine. So just put your phone on airplane mode. You will see the notice, then disable the airplane mode. The notice will disappear. Okay. So we have reached the end of this section. I will see you in the next section. In this section, you're going to learn how to implement authentication in your React Native apps. As part of this, we're going to take our app to the next level and make it even better. So by the end of this section, users will be able to register and log in. So let's jump in and get started. There are many solutions available to authenticate users. The most popular ones are Amplify by Amazon, Firebase by Google, and Auth0. All these platforms make it really easy to authenticate users. But in this course, we're not going to use any of these commercial solutions for 2 reasons. One is that not everybody likes or can afford to pay for these services. So I didn't want you to hate me for teaching you something you don't want to use. The second reason I didn't want to use any of these solutions is that their API may change from time to time. So I didn't want my course to get outdated because of these changes that are out of my control. So I've rolled out my own authentication solution. I'm going to explain how it works. So if you want to implement it using Django or Rails or ASP.NET, then you know what you need to do. And by the way, all these authentication providers that I mentioned, they work in a very similar fashion. So in this section, you will learn the essence of authenticating users. So next, I'm going to explain my authentication solution. So here's our app. When the user logs in, we should send a post request to the auth endpoint of our backend. Our backend, in this case, our node server, validates the email and password. And if they're valid, it returns what we call an authentication token or auth token for short. It's like an ID card, like a passport or a driver's license. In reality, it's just a long string that's been encrypted and digitally signed. We'll talk about it in more detail later. So we receive the auth token. Now from this token, we can extract basic information about the user, like their user ID, their name, and email. In the same way, we can look at someone's passport and get some basic information like their name, place of birth, and so on. So we extract a user object from the auth token and then store it in the app component. So in the app component, we should have a state variable called user. Now, if the user exists, we're going to render app navigator. So that will take the user to the home screen of the app. Otherwise, if the user is null, we're going to render auth navigator to take the user to the welcome screen. Now let's say somewhere in our app, like the account screen, we need to access the current user object that is stored in the app component. We don't want to pass this object down to every component in the component tree. That's a bad practice, and there's actually a name for it. It's called prop drilling, because it involves drilling a hole or a prop at every level in our component tree. Now John is back and says, okay then, we need Redux. No, we don't. We can use React Context. It's a lot simpler. Using React Context, we can provide an object in our app component, and any component in our app will be able to consume this object. So does it mean React Context replaces Redux and Redux is no longer needed? No, it doesn't. Context is suitable for sharing small objects that don't change often, like our user object. Once the user logs in, the user object is not going to get changed, right? If you share a large object with React Context, any changes to this object will cause your entire component tree to re-render. So even if a component is not interested in the changed properties, it will get re-rendered. For sharing large objects that change frequently, you should use Redux. With Redux, components can subscribe to the Redux store, and they will get re-rendered only when the data relevant to them get changed, okay? So next, we're going to implement the navigation aspect of the authentication flow. Let's start off by testing our authentication API. To do that, we're going to use Postman. It's a tool for calling HTTP endpoints. You're probably familiar with it. In the past, Postman used to be a Chrome extension, but that extension is deprecated. Now you can get it as a standalone app. So head over to postman.com/downloads and get the latest version. Okay, here's Postman. Now let's add a new tab. We're going to send a post request to our authentication API. That is localhost port 9000/API/auth. Now in the body of this request, we're going to send a JSON object. To do that, we're going to select raw and set the type of the data to JSON. Now we add the JSON object. We should surround the keys with double quotes. So we pass an email. We set it to mosh@domain.com. And we also set the password to 12345. Now this is a valid email and password combination. So when we send this to the server, we're going to get an authentication token. Take a look. So send. Now we go back to the first tab, params. There you go. So here's an authentication token. This is essentially a JSON object that's been encrypted and digitally signed. We'll talk about it later in this section. Now let's see what happens if we pass an invalid email or password. So back to the body tab. I'm going to change the password to something else and send this request. Now, look, we get an object with the error property saying invalid email or password. Now look at the status code for this request. That is 400, which means bad request. And this happens when the client makes an error, when the client posts the wrong data. This is just a common REST convention, okay? So now we're going to go to our front-end app, and in our API layer, we're going to add an object for calling this endpoint. So here in the API folder, let's add a new file called auth.js. First, we're going to import client from the current folder. Then we're going to define a function called login, which takes an email and password. And here we call client.post. Our endpoint is /auth. And here in the body of the request, we should pass an object with two properties, email and password. And finally, we need to export this using a default object. Okay, so our API is ready. Next, we're going to use this on our login screen. Our API is ready. Now we should use it on the login screen. So let's go to login screen. First, on the top, we're going to import auth API from we go up to API/auth. Next, look at our form. We're going to replace this inline function with a function called handle submit. And then we're going to implement it here. So handle submit is a function that takes the values in the form. We can call this login info. That's better. Now here we're going to call our API. So auth API.login. We need to pass the email and password. So we can destructure this argument and grab the email and password properties. And then we pass them over here. This returns a promise, so we await it to get the result. Now we should make this async. So we get the result. Now, if result is not okay, we want to show an error. To do that, we're going to go on the top. So earlier we imported 3 components from our forms module. Now let's add another component here called error message. We're going to add that right above our first form field. So error message. Here we should set 2 props. Error. We can hard code an error message here like invalid email and or password, or we can use the error message that we get from the server. Now in this case, the only error message that we get is the one that we have hard coded here. So it doesn't really matter whether we hard code it here or get the error message in the response. So here's the error. Now we want to show this only if we have an error. So here we need to declare a state variable and set it to true if the login fails. So that is super easy. Here we're going to call useState. We're going to initialize our variable to false and call it login failed. And the function to update it, set login failed. So if the result is not okay, we're going to set login failed to true. And we want to return immediately, so the rest of this function is not executed. Now for testing, if everything goes well, we're going to set login failed to false. And then we're going to log the auth token on the console. So console.log result.data. Okay, so the last piece, here's our error message. We're going to set visible to login failed. Now save the changes. Okay, now we need to go to app.js and temporarily replace the app navigator with auth navigator so we can see the welcome screen. So auth navigator. Good. So here's our app. Let's log in with mosh@domain.com. Here I'm going to enter a wrong password. So 12345 with a hyphen at the end. Log in. We see the error. Now let's remove the hyphen and log in. The error is gone. And here's the authentication token in console. Next, I'm going to show you how to extract the user object from this auth token. Now let's take a closer look at this authentication token. So I'm going to grab this, copy it. Now let's go to jwt.io. This is the official website for JSON Web Tokens. So the authentication token that you saw is actually called a JSON Web Token. So over here, we have a debugger for debugging a JSON Web Token. So on the left side, you can see a JSON Web Token in the encoded format. And on the right side, you can see what it looks like when it's decoded. So let's delete what we have here and paste our authentication token. So here we have 3 sections, a header, a payload, and a signature. A header is just an object with 2 properties, alg or algorithm, which is the encryption algorithm, and type, which is set to JWT. We don't really care about the header. What we care about is the payload. So here we have a user object with 4 properties, user ID, name, email, and IAT, which is short for issued at. This is the timestamp of the moment when this token was generated. Okay. Now look at the signature. So here we have this function called HMAC SHA-256. This is an encryption algorithm. Now look at the arguments of this function. We're getting the header, encoding it using base 64 algorithm. Then we append a period, and then we get the payload and encode it using the base64 algorithm one more time. So both these objects, the header and the payload, they're encoded using the base64 algorithm. Now the result is encrypted using a private key. This private key should only be available on the server. Now here the private key is by default is set to your 256-bit secret, and that is why we have this red box on the left, because this is not the key that I used to generate this token. So here in our backend project, inside the routes folder, look at auth.js. This is the implementation of our auth endpoint. Now look over here. This is the private key that I have used to sign this token. Now in this implementation, I've hard-coded the key in the source code. This is a terrible practice. You shouldn't do this in production. If you store the key in the source code and then check it into a code repository like Git, anyone who has access to your code repository can find the key and abuse it. The proper way to store the private key is using an environment variable. I talked about this in detail in my Node course. So if I grab this key, get back here, and use this key, the red box is gone. So using this key, we can generate and validate a JSON Web Token, okay? So now that you know what a JSON Web Token is, let's see how we can decode it to get access to the payload. And by the way, for decoding this token, we don't need this private key. The private key is only used for generating and validating the token, but not for decoding it, okay? So here we shouldn't store any sensitive information like user's password or credit card numbers. We only have public information about the user, like their ID, their name, and their email. So now back in our front-end project, let's install a library called JWT-decode. With this library, we can decode JSON Web Tokens. All right, I'm using version 2.2.0. Now, back to our login screen. On the top, let's import a function called JWT-decode from JWT-decode. So when the user successfully logs in, instead of logging their authentication token, we want to decode it and log the user object. So here we're going to call JWT-decode, pass result.data, and then store the result in a user object. Now let's log this on the console. So here's our app. Let's log in one more time. Here in the console, you can see the user object. Beautiful. So next, we're going to store this in the app component and make it available for the entire app. Now that we have this user object, we should store it in the app component and make it available to our entire app. So let's go to app.js. Earlier, I told you that here we should declare a state variable for storing the current user. So we call the state hook and declare a variable called user. Now we should make this object available to our entire app. To do that, we're going to use React Context. If you have never worked with React Context, don't worry, I'm going to explain exactly how it works. So here in the app folder, let's add a new folder called auth. We're going to write all our authentication code inside this folder. So let's add a new file here called context.js. Here we should create a React context object. So first we import React and then call React.createContext. This returns an object. We're going to call that auth context. Now the reason I'm using Pascal naming convention here is because we're going to use this object in our JSX expressions. So auth context has a couple of properties, provider and consumer. These are both React components, okay? So let's export auth context from this module. All right, now back to our app component. We're going to wrap our entire app with auth context.provider. So instead of this fragment, we're going to use auth context.provider, and then we need to close it over here. Good. Now with this provider, we can provide a value to our entire app. So the object that we pass here will be available to any components below this provider, okay? So we can pass the user object, and every component will be able to read the current user, but they will not be able to change the current user. In our login screen, the moment we get this user object, we need to update the user variable in the app component. So in addition to the user object, I also want to pass the function for updating this object, okay? So here we're going to pass an object with two properties, user and setUser. Okay, now we go to the login screen. Here we want to access the object that is provided by the auth context. So we're going to use another hook called context, use context. Here we should specify the type of context we're interested in, because in a real app, we could have multiple context objects. So we can have a context for the current user and another context for the current theme, okay? So here we specify the type of context, auth context. Now this returns an object, let's call that auth context. This object is exactly the object that we have passed over here, okay? So when we extract the user object from our JSON web token, instead of logging it on the console, we're going to call auth context that set user to user. This is going to update the user object in our app component. Now the final step, instead of rendering auth navigator here, we want to conditionally render different navigators depending on the authentication status of the user. So if we have a user object, then we're going to render app navigator to take the user to the main screen of the app. Otherwise, we're going to render auth navigator so the user can see the welcome screen and log in. Let's test our app. Okay, here's our app. Let's log in with mosh@domain.com and 1, 2, 3, 4, 5. Beautiful, it's successfully logged in. So let's move on to the next step. Look at the account screen. Here I've hard-coded my name and email address. Let's replace these values with the properties of the current user. So we go to account screen. Once again, we're going to use the context hook. So use context. We pass auth context here and get auth context. Now we can destructure this object and pick the user property and then use it to replace these values. So I'm going to set title to user.name and subtitle to user.email. Now the user object that we get from the server doesn't have a property for the image. So we're going to leave this image the way it is. Now back to our app. So now we can dynamically display the name and email of the current user. Next, I'm going to show you how to implement the logout feature. So here in the app component, if we have a user, we render the app navigator. Otherwise, we render the auth navigator. So to implement the logout feature, all we have to do is to set the current user to null. So back to the account screen. Currently, we are only picking the user property of the auth context. Let's also pick the setUser function. Now, down below, here's our logout menu. Let's handle the onPress event. So onPress, we set it to a function, and in this function, we call setUser to null. That's all we had to do. Take a look. So save the changes. Here's our app, logout, beautiful. I'm going to log in with a different user, john@domain.com, and the password is 12345. Now we have John's name and email. Perfect. But there's a problem with our app. If I reload the app, we get back to the welcome screen. I will show you how to fix this in the next lesson. To keep the user logged in across app restarts, we should store their authentication token in a persistent storage and then restore it when the app starts. So here in the auth folder, let's add a new file called storage.js. So this module is responsible for storing and retrieving the user's authentication token. It's an abstraction over a persistent storage, just like the cache module that we implemented earlier. So here we're not going to use async storage. We're going to use secure store in Expo. So this is a separate library we have to install. So let's grab this and run it in the terminal. All right, now back to the storage module. On the top, we're going to import everything as secure store from expo-secure-store. Now here we need to define three functions. The first function is store token. It takes an authentication token. And here we should call secure store.setItem async. We need to pass a key. I don't want to hard code a key here because we have to use it multiple times in this module. So let's define it as a separate constant. We can call it auth token. Now we pass the key and the auth token. This method returns a promise, so we need to await it and make this async. Now we need to wrap this inside a try-catch block in case this operation fails. So let's add a try-catch block, move this up here, and for now we're going to log the error on the console. So error storing the auth token. Okay. Now the second function. We need another function for getting the token. So get token is a function. Here we call secure store.getItem async. We pass the key, await the call, and get the token, auth token. Now let's wrap it inside a try-catch block. So real quick. Okay. So if we get the auth token, we're going to return it. Or we can combine these two statements. We don't really need this variable or constant. So let's return straight away. Now, if something goes wrong, we're going to log that error separately. So we say error getting the auth token. Now we should also make this async. Now, the reason we're handling errors here is that we're going to use these operations in multiple places in our app. So if we don't handle the errors here, we would have to duplicate our error handling logic in a few places in our app. Okay. So we have two functions. Now the third function. Remove token. We're going to use this when the user logs out. At that point, we should remove their authentication token from the secure store. So this is a function. Here we call secure store.delete item async. We pass the key, await the call, and make this async. And finally, handle the errors. So here we say error removing the auth token. As I told you before, in a real production app, instead of login to the console, we should use a login service so we can monitor these errors. We'll talk about this in the future. So here we're going to export an object with three properties: get token, remove token, and set token. We're done with this module. Now, here in the login screen, the moment the user logs in, we should store their auth token. So we import the storage module, but I want to rename this to auth storage. That is more clear. Now have a quick look at our import statement. So we're importing auth storage from auth/storage. Okay. So here we call auth storage dot set token. I actually made a mistake here. I should have called this store token. So real quick, this should be store token. All right. So this should be store token. So we call this method and pass result.data. Now, when the app restarts, we should restore the token. So we go to our app component. Now here I'm going to use the effect hook, but this is not the right place to restore the token. I'll talk about the right way in the next lesson. For now, let's just use the effect hook. So here we should use our storage service. Once again, I'm going to rename this to auth storage. Now, because we have an async call, we have to put this in a separate function. So I'm going to call that restore token, an async function. And here we call auth storage.get token. We await the call and get the token. Now, if the token doesn't exist, we're going to return immediately. Otherwise, we should decode the token to extract the user object. So on the top, we're going to import JWT decode from JWT-decode. Now, Here we call JW to decode. We pass the token, get the user object. Now we don't really need to define a separate object. Here we can directly call setUser and pass the object that is returned from this function. We're almost there. Now, back to the effect hook. Here we call restore token, and we want this to be called only the first time our app component is rendered. Now the last step. When the user logs out, we should remove their authentication token. So here in the account screen, this is where we're handling the logout. So I'm going to replace this with a function called handle logout. Now, let's implement that function. Okay, here we're going to call setUser and pass null. Then we're going to use the storage service. Let's rename it to auth storage and call remove token. Now, we don't need to await the call because we don't have to wait for this to finish to do something else. We're basically done here. So let's test our app. Now, I'm going to log out, log in from scratch. Okay, now let's reload the app and make sure we're state logged in. Beautiful, but there is a tiny problem. Did you notice the welcome screen? Let me show you one more time. So, reload. The welcome screen flickered for a fraction of a second. I will show you how to fix this problem in the next lesson. Now, let's log out. We reload the app, and we're still logged out. Perfect. So next, we're going to improve this and get rid of the flicker. If you have noticed, when our app starts, we see a screen like this. This is called the loading or the splash screen. Let me show you. So here's our app. Let's reload it. Did you see the loading screen? Currently, the loading screen becomes visible and then disappears pretty quickly. If we keep it on while restoring the token, we can get rid of the flickering issue. To do that, we're going to use the app loading component in Expo. With this component, we can control the visibility of the splash screen. So let's go to app.js. On the top, we're going to import app loading from Expo. Now, in our component, we're going to declare a state variable that tells us if our app is ready or not. So use state. We're going to initialize this to false and call it is ready. Now, we no longer need the effect hook. Let's get rid of it. So if our app is not ready, we're going to return the app loading component. At this point, we're going to see the loading screen. Okay. Now, to control the visibility of the loading screen, here we should set two props. The first one is start async. We set it to a function that should be called when our app starts. In this case, I'm going to set this to restore token. Restore token. The other prop we should set is onFinish. This is an event that gets raised when the execution of this function is finished. So here we want to pass a function. And in this function, we want to call setIsReady and pass true. In the next render, isReady is true. So instead of the loading screen, we're going to see the main screen of our app. Take a look. So save the changes. Here's our app. Let's reload it. Here's the loading screen and here's the main screen. So the welcome screen didn't flicker. Now let me show you how to replace this boring loading screen with something more interesting. Download the image below this video and put it in the asset folder. With that, when you reload the app, you see this beautiful screen. But if you noticed, we have some white edges around the red screen. Let me show you. So look, here are the white edges. To fix this problem, we go to app.json. So here we have a property splash. Here we can see the address of the splash screen. Below that, you can see the resize mode. Currently, it's set to contain. We can change that to cover, and this will resize the image with the right aspect ratio to cover the entire screen. Now, we also have background color, which is set to white. We should change this to the background of the image because loading the image might take a fraction of a second, and during that time, our splash screen is going to be white. So change that to E 63C4B. Done. Now, let's reload the app one more time. Perfect. So we have successfully implemented the authentication flow, but there's a problem in our app component inside this function. Can you tell? Our app component knows a bit too much about authentication. It knows that it has to extract a token from the storage and then decode it to set the current user. These details don't really belong here. Our app component should be like a manager who delegates work to others. So I'm going to extract this logic from here and move it into our auth module. The details of getting a token and decoding it really belong to the auth module, okay? So here in the auth folder, let's go to storage.js. So here's our get token function. We shouldn't really export this function from this module because other modules using this function then have to be responsible for decoding a token. So down below, let's remove get token. Good. Now we're going to create a new function. Let's call that get user. This function calls get token. We await the call to get the token. Now let's make this async. So if we have a token, then we're going to decode it. So on the top, let's import JWT decode from JWT-decode. Now, let's go to get user. So over here, if we have a token, then we're going to decode it and return the result. Otherwise, we're going to return null. Or we can combine these two statements and make our code cleaner. So return. If we have a token, we're going to decode it and return it. Otherwise, we're going to return null. That's better. So this is the function that we should export from this module. So down below, get user. Now back to the app module. So here we're going to call get user. We get a user object. So let's rename this to user. Always pay great attention to the name of your variables. So we get a user. Now, if the user exists, then we're going to set the current user. We don't need this line, so delete. Now let's also rename this function to restore user, because that's what this function is really doing, right? So save the changes. Now on the top, look, we no longer need the effect hook because now we're using the app loading component. Also, we don't need to import the JWT decode function either. Again, the logic of decoding a token doesn't really belong here. It's too detailed for the app component, okay? So, good. Now, let's test our app one more time. Okay, here's our app. Let's reload it. I'm still logged in, good. Now I'm going to log out and log back in. And reload one more time. Perfect. Now let me show you something really interesting. So we go to account screen.js. Now look at this line over here. Every time we want to get the current user, we have to use the context hook and pass auth context as an argument. Now there's nothing wrong with this, but wouldn't that be nicer if we had a custom hook that we could use like this? So instead of importing the context hook and auth context, we would only import our custom hook. Let me show you how to do this. So here in the auth module, we add a new file called useAuth. Here we define a function called useAuth and export it straight away. So export default. Now in this function, we should do what we are doing over here. So we use the context hook and pass auth context as an argument. Now we destructure the result to get user and set user, and then return them over here. Pretty simple, right? Now back to account screen. Let's replace this with use auth. Our app should work exactly like before. Let's verify it. So here's our app. Let's go to the account screen, and here's the current user. Beautiful. Now let's take this to the next level. Look at the handle logout function. Here we're setting the current user to null and then removing the token from the storage. We can encapsulate these details inside our custom hook. Let me show you. So over here, I'm going to define a function called logout, and then move this logic to our new function. So we set the current user to null. Now here we need to access the auth storage. So let's import it on the top. Import auth storage from storage. Again, because currently we are inside the auth module or auth domain of our app, both the context and storage modules are right next to us, okay? So here's our logout function. Now, let's export it from here. Save. Back over here. So we don't need the set user function anymore. Let's get the logout function and call it right here. In fact, we don't even need this function. It's unnecessary. We can call logout right here. So when we handle the onPress event of this menu, here we pass a function and call logout. As simple as that. So let's get rid of this function. Good. Now on the top, look, we no longer need the context hook, so delete. And we don't need auth context and auth storage either. So our code is cleaner. This component or this screen is purely responsible for the UI. All the business logic is moved to our custom hook. Now we no longer need to export set user. So we only have user and logout. Using the same technique, we can refactor the login screen and move the login logic over here. So let's go to login screen. So here in the handle submit function, the moment the user logs in, first we have to decode their token to get a user object. Then we have to set the current user and then store their token. These three lines are the business logic of the login functionality. They don't really belong here. We should move them to our custom hook. So I'm going to select these three lines, cut. Now back over here, let's define a new function called login. Paste them here. Here we need to decode the token. So first let's import JWT decode from JWT-decode. Now we need to add a parameter here, auth token, and then pass it over here. Next, we need to set the user. So we call the set user function directly, and then we need to store the token. We already have auth storage here. Let's replace this argument with auth token. Good. Finally, let's export our new function. Login. Good. Now back to the login screen. So we no longer need to import use context and auth context. We can simply use our custom hook. Here we get the login function and call it over here with result.data. Now, if you don't like to call this function like this, if you think this is ambiguous, you don't have to use object destructuring here. You can simply store the result in this object and then call auth.login. That's another approach. Now let's go to the top and clean up some code. So we don't need the context hook, delete. We don't need the decode function either. Good. And we no longer need auth context and auth storage either. So our code is a lot better. It's a lot cleaner. When you separate the concerns in your code always looks really simple and clean. If you have a lot of code in one module, if you have a lot of import statements, it's very likely that you haven't separated the concerns properly. Okay? So let's test our app one more time. I'm going to log out, log back in. And perfect. Quite often, we have endpoints that can only be called by authenticated users. For example, in our backend project, we have this endpoint for getting the listings of the current user. This endpoint requires the user to be authenticated. So if we call it, by default, we get an error with the status code of 401, which means unauthorized. And in the body of the response, we get this error saying access denied, no token provided. So to call this endpoint, we have to pass our authentication token in the request header. First, I'm going to show you how to do it here, and then I'm going to show you how to do it in code. So we go to the headers tab, add a new key. Now in my implementation on the server, I expect a key called x-auth-token. Now for the value, I'm going to paste an authentication token, send. So now we can successfully call this endpoint. So here are my listings. Now let's see how we can do this in code. So let's go to client.js. Here we need to apply a transformation to our requests. So every time we send a request to the server, we automatically include the authentication token. With this, we don't have to worry about sending the authentication token for individual requests. So after we create this API client, here we call API client.add async request transform. Here we pass an async function that takes a request object. And this is where we're going to transform our request. So first we need to get our authentication token. So on the top, let's import auth storage from, we go up to auth/storage module. Now we need to go to this module and export the get token function. So over here, get token. Now back to the client module. In our transformation function, we call auth storage.get token. We await the call to get an auth token. Now, if we don't have a token, then we're going to return. Otherwise, we're going to add the authentication token in the request header. So request.headers of the key that our server expects is x-auth-token. We set that to auth token. As simple as that. So this is how we can call protected API endpoints. Now, if you're curious how this works on a server, look at this auth module inside the middleware folder. In this function, we look for a header called x-auth token. This is where we have the auth token. If we don't have a token, we're going to return a response with a status code of 401. And in the body of the response, we're going to add this error object, access denied, no token provided. Otherwise, we're going to verify the token using this library, JSON Web Token. So this is a separate library that I've installed with NPM. Now, if you're building your backend with, let's say, Ruby or Python or C#, then there is a separate library you need to install to verify JSON Web Tokens. So here we verify the token using the private key that I told you about earlier. Now, once again, we shouldn't include the private key in the source code. This is a terrible practice. This is purely for demoing. So we verify the token. If we have a valid token, we get the payload, which is a user object. So we store it in the request so we can access the current user. Now, if the token is not valid, this line is going to throw an error. So we'll end up in the catch block. And here we return a response with a status code of 400 and say invalid token. Now, as your exercise, I want you to implement the registration function. So we have an endpoint for registering users, that is /users. In the body of the request, we send an object with 3 properties, name, email, and password. Now, if you have a user with this email, we get a bad request. So a bad request, and in the body of the response, we have this error saying a user with the given email already exists. Otherwise, if we send a unique email, let's say Mosh1, in the body of the response, we get the registered user. So go ahead and implement this functionality. If there is a user with this email, make sure to display an error message here. Otherwise, once the user registers, automatically log them in and take them to the main screen of the app. This is really easy. It shouldn't take more than 15 minutes of your time. Let's look at my implementation of the registration function. So now we have a new API called users. Here we have a function called register, which takes a single object. So instead of having 3 parameters here, like name, email, and password, we have a single object that encapsulates all these values. And with this, we can simply pass this object in the body of the request. If we have 3 parameters here, and then tomorrow we decide to add a new field to our form, like birth date, we would have to add that here as well. Now with this user info object, we don't have to worry about this. This is the benefit of passing objects around, okay? So here's our new API. Now in the register screen, we have this handle submit function, which takes a user info object. This is the object that format gives us. Again, we take an object here and we simply pass it to the register method. If we destructure this and picked name, email, and password, and then tomorrow we decide to add a new field to our form, let's say birthday, we would have to add that here. Then we would have to pass that to the register method, and then we'll have to add that here and here as well. We don't want this to happen. So this is the benefit of passing objects around. So let's bring back user info. Good. So we use our API to register the user. Now, if something fails, first we have to figure out why it failed. So if result has data, that means the server properly processed our request and sent us an error. That is this error object over here. So in that case, we're going to set the error to result.data.error. Error is a state variable that I've declared over here. It contains an error message. Okay. Now, otherwise, if the server didn't send us the data, that means something unexpected happened. Maybe the server is offline or there is no internet connection. Now, I know we have an offline notice component for taking care of this, but I thought it's good to show a generic error message and log this error as well. Now, once again, we're logging the error on the console, but in a real app, we should log it using a login service. So then we return. So the rest of this function is not executed. Otherwise, if we successfully register the user, then we use our auth API to log in the user. So we send the user's email and password to the server to get their authentication token. So here I'm destructuring the result or the response object. I'm picking the data property and rename it to auth token. And then we use our auth hook to log in the user with this token. So let's test my implementation. We're going to register with my new email, which already exists. So we get this error, beautiful. Now, what if we pass a new email? We see the home screen, beautiful. So here I'm simulating a slow connection using React Native Debugger. I already explained how to do this early in the course. So if you missed that, look for the lesson called Simulating a Slow Connection. So let's see what happens if the user tries to register on a slow connection. Look, we don't give the user any visual feedback, and that's really bad. So let's quickly add an activity indicator. To do that, we're going to use our API hook that we built earlier in the course. So use API. So with this hook, we can call an API endpoint, and this hook takes care of the loading state. So let's go to our register screen. Here we're going to use our API hook. And here we should pass an API function. What is that function? That is the function we're calling over here, users API.register. So let's add that over here. Now we get an object. Let's call that register API. As you remember, this object has a bunch of properties: data, error, loading, and request for calling the server. So we're going to replace this with register API.request. We have another API call down below for authenticating the user. So one more time, let's copy this and use our API hook. We pass auth API.login. We get an object and call that login API. And then we replace this with login API.request. Now we need to add an activity indicator. So over here, let's add an activity indicator. I'm going to import the activity indicator component that we built earlier in the course, not the one in React Native, okay? So let's add that. We want to show this when our register API is loading or our login API is loading. So login API.loading. That's pretty much it. So let's test our app, register. Here's the activity indicator, beautiful. But where is the main screen? Well, we have an error. Look in the console. Cannot read property OK of undefined. So over here, after we call the server to register the user, we're checking the OK property of the result object. In this case, result is undefined because we have a bug in our API hook. So let's go to use API. Here's the register function. Look, if the response is not OK, we are returning set error of true. Here we should return the response object. Okay, so let's wrap this in braces. First, we set error to true, and then we return the response object. Now, what if the response is OK? We are not returning anything. Again, we should return the response object. Now, this code looks a bit ugly. We can simplify it. We can combine these statements. So if the response is not OK, we're going to set the error to true. Otherwise, we're going to set it to false. So we can combine these into a single statement. So set error to not response.OK. Now we don't need these two separate statements. Now similarly, we're going to set the data to response.data, whether we have an error or not. There is no harm in doing so. So I'm going to bring this up. We're left with our return statement. So whether the response is OK or not, we're going to return the response. So let's get rid of this if block. Good. So here's the end result. It's a lot better. Now let's test our app one more time. So register, we have our activity indicator. We got an error from the server. Now let's register a new user. Good. Perfect. Now we get this warning, an unhandled error was caught. This is from before, so don't worry about it. So we have implemented the activity indicator, but there is a tiny problem. Let me log out and register one more user. Okay, take a look. We see the activity indicator, but I can still access the register button. It would be better to show the activity indicator using an overlay, and that's what we're going to do next. So here on the register screen, I want to temporarily set the visible prop of the activity indicator to true, so we don't have to keep creating users while testing the look and feel of this component. So let's set this to true. Good. Now let's go to our activity indicator component. To implement an overlay, we should wrap this Lottie view inside a view. So here we add a view. Now we should apply a bunch of styles. So on the top, let's import the style sheet module. And then we should create a styles object. I'm going to call this overlay. Now, what styles do we need here? Well, we want the overlay to take the entire screen. So I'm going to set the height and width to 100%. Now for testing, I want to set the background color to black so we can see this clearly. Now, before going any further, let's see what this overlay looks like up to this point. So I'm going to apply the styles to this view. Styles.overlay. Now take a look. Here's our overlay. Now, if you pay close attention to your simulator, you will notice that the overlay has pushed down the registration form. You cannot see it in my recording window, but the form is right here. So to prove that to you, I'm going to set the position property to absolute. So the overlay is positioned irrespective of other components on this form. Take a look. So save. Now the overlay is positioned regardless of other components on the form. However, we have a bit of layout issues. For the starter, the overlay is not covering the navigation bar. Honestly, I don't know how to do this. As far as I know, the navigation bar always stays on the top. But to get rid of this padding issue, let's go back to the register screen. So this activity indicator should take the entire screen. So it's like a screen component on its own. It doesn't make sense to add it inside the screen component. That is the reason why we have that padding. So let's take it out and wrap these with a fragment. Okay, that looks better. But currently, the register button is still accessible. We want to bring the overlay and put it on top of these components. To do that, we're going to set z-index to 1. Now the overlay is completely covering the form, beautiful. But let's change the opacity so we can see what is underneath. So opacity, I'm going to set it to 0.8. That's better. Now, I would prefer to change the black tint to white. That is cleaner and more modern. So white. Here's the end result. I really like this. I think it's beautiful. So back to the register screen. Let's set the visibility of the activity indicator to register API.loading or login API.loading. Okay. Now let's register a new user. Okay, beautiful. We see the activity indicator. However, our listing screen looks a bit odd. We'll fix that in a second, but we also have this warning: can't perform a React state update on an unmounted component. I think this is just a temporary issue. If we reload the app, it's going to go away. So let's not worry about it for now. Instead, let's go to the listing screen. So here we have this activity indicator inside the screen component. Once again, we need to take it out and wrap these inside a fragment. Okay, let's test our app one more time. Perfect. So I'm going to log out and register one more time to make sure everything works. Okay. Perfect. So we're done with this section. I will see you in the next section.